Hey, what's up, people? Fire up your DeLoreans and set your time circuits to 1965 because that's when this actually, I don't know exactly when this thing was first available for purchase as a kit or when it was actually built, but there is a date on the assembly manual down here at the bottom of the first page where it says June 11th of 1965. So somewhere in that time period, this thing came out. But anyways, it's a Heatkit tube checker model IT-21, and it's for checking tubes like cheese. I mean these, and I almost dropped one. So uh, I'd been looking for one of these things for a while, not like this exact model or anything like that, just a like a tube checker or a tester like in general. But a lot of times these things are pricey, especially if you find one that's like in good condition and working and, calibrated, tested and all that. I was just looking for something basic, and I happened to come across this one at a swap meet or a flea market, whatever you want to call it. And the person that was selling it there was selling it for $75. And so I thought the price was kind of reasonable. If you look on eBay for these, they go for a lot more than that, or sometimes, plus the shipping, it's like way more than that. This one caught my attention due to the fact that it had the assembly manual, and it also had three other tube data booklets for, like various tubes. And I think, let's see, we got this one's from 74. I think we have up to 78. So it has a lot of, 75 and 76. So it's got quite a lot of information about a lot of tubes there for, like setting all the knobs and the switches and all that. And I don't do like any tube repairs or anything like that. I want to like dabble in it. And I actually do have this really old oscilloscope. It's a Hickok scope from like the 50s that a friend of mine actually found next to a dumpster, and he took a picture of it, sent me. He's like, "Do you want this?" I was like, "Oh, heck yeah." So I would like to restore that, and I needed something to be able to test tubes with. And even though this doesn't do like any crazy extensive like testing of tubes, I'm hoping that it'll at least, give me an idea of like which tubes might be good, which ones are bad. And then that way maybe I can like look for replacements and whatnot. This thing is actually in pretty decent shape. It's got a bit of dust on the knobs and a little bit of dust on like the surfaces. It's got a little bit of dirtiness on the case. Really not that bad though. And on the back, it has the sort of little plastic feeling feet. And I think that's so you can kind of like lay it on its back, and it'll clear the cord there, so it's not like, rocking or teetering or anything. And the cord, though, I think I do want to replace. This one's kind of stiff and sticky, and it's not polarized, so it can pretty much go in like either way into an outlet. And so I do have a cord that I bought. It's a 6-foot extension cord, and I'm basically just going to like cut off the end that I don't need. And the cable itself is a bit like bigger in diameter than the original, but it looks like this one doesn't even really fill the grommet completely. So I'm hoping that this one will fit. And as I mentioned, this is polarized, so I'll be able to get the alive to go through the switch before it goes to the rest of the circuitry. Whereas this one here, the live can be going through the components before it gets to the switch. And so just to prevent that, I think I do want to go with this route. All the sockets, I don't see like any corrosion. They actually look pretty clean, at least externally. The only issue it does seem to have is that on the chart that rolls where you can select the tube to view like all of the settings for the knobs and the switches, when it gets up to in the ones, it kind of jams up right there. And I know that there's still more numbers because you can kind of see them, but right there, it just kind of stops. So we're going to see what's going on with that, try to fix that. And the movement looks like it's in pretty good shape. So overall, I don't think it's going to be too bad. I don't think there's going to be like any real serious stuff to have to repair inside. So it's got 2 screws on the back that we can remove so that we can get inside. And these should come off fairly easily. So this should allow the backside here to come off. But I do need to undo this so that I can get it in through that hole. Or actually, maybe not. Let's see. All right, and this wants to tilt back, so let's try to push this cable through. Oh yeah, that went completely through. Here we go. Well, The inside's a little dusty, but it's really not that bad. Yeah, if I can put this on the side, that way it'll just kind of sit there. So yeah, a little bit of surface dust, but not bad at all. And this cable that we just see kind of floating around, it's a cap lead, so that if you have a tube that has a cap on top, you just pull this out and clip it onto that. And this cable feels it kind of sticky on the surface, so that's going to need some cleaning. And then over on this side, we have the roll here. So we should be able to get up to this portion where it says stop. And yeah, see, it's stopping right there a little too early. This is where it gets kind of hard to turn. Oh, I see what's happening. When it starts getting towards the end, these two wheels on the side start getting too close together, that the plastic starts rubbing. You can see it down there, right there. It's like rubbing against each other, and that's what stops it from moving. So I don't know what could possibly prevent that from happening. I mean, it doesn't seem like it should have to do that, or it should want to do that, because this is spring-loaded on the sides. And I like how the end of this is just taped to the cylinder. Yeah, I think I'm going to have to look in the manual and see if there's a way that this thing's supposed to be set, because when we go in the opposite direction, we start getting to a point where it also starts like rubbing on the two wheels right there. And as we can see, we still have a lot of paper left on that cylinder. So that can't be right. And I noticed that when it gets to like somewhere in the middle, we can see that the two cylinders are separating away from each other. It gets to a point where it kind of has like the maximum amount of separation, and then they start getting close again once one of the cylinders starts running out of paper. So as I get closer to the end of this cylinder, it starts moving back close to the other side. So yeah, we'll look in the manual and see how exactly these gears are supposed to be set so that that doesn't happen. Maybe it'll mention it. That switch looks like it's definitely going to require some cleaning. It looks like it's way tarnished on the surface. These other ones also don't look very hot, but if this thing was stored for, like years or decades, then it's no surprise that these things are all tarnished. And on the back of the tube sockets, they look pretty good. I mean, I don't see any issues there. Maybe we'll give this switch a bit of a cleaning internally. And on the other side, all those sockets also look pretty good, at least from the back side. And here's another switch. This is the test switch, so we'll give that a spray inside. Not a whole ton of components. We can see we've got some resistors in this area. I will check those, make sure that they are, what their values are supposed to be. This capacitor I will replace, and actually do have a replacement for that. But other than that, not bad. And we can see that the power cord comes straight into these two solder terminals. So that's going to be super easy to deal with. And all of these wafer switches in the front are going to need a cleaning as well. We can see we've got quite a few terminals there, but it's only like a 3-position switch. So it's like down, middle, and then top. So I think as long as I maybe put some contact cleaner on those and then just kind of work them back and forth, should be able to get them pretty clean, because otherwise it would require having to dismantle this entire assembly. And as you can see, everything's like nicely loomed in there. So I don't know if this loom came like pre-built like that, or if whoever assembled this tied it up. But I mean, that's really, really neat. Okay, so let's look in the manual and see what it says about these paper cylinders. So this has like all the information you need about this thing, how like the circuits work, and what components are used. This is that capacitor they're going to replace, and that's a 0.1 microfarad tubular capacitor, dude. So let's try to find the part where it talks about the rolls, and it shows it right there. Oh, let's see, does it say anything about it? Okay, there's a little note on the side here of detail 8A. It says, note, torque required to turn drive knobs can be adjusted by position of retaining rings. So the retaining rings are those, but that just looks like it holds the shafts from being able to come out the side. So I don't know if it's talking about like maybe, putting friction against the plate, because otherwise I don't see how that would adjust it like that. Okay, I think maybe this is the information we need. It says refer to pictorial 13 for the following steps, and this is pictorial 13, and it's talking about the roll chart. So it says install the roll chart on the drive roller as shown in pictorial 13A. Line up the bottom of the chart with the separation line between the two halves of the roller. Tape the chart to the roller with the masking tape provided. I don't think I want to remove any of the old masking tape that's on there. I have a feeling I'd probably end up causing more damage. It says to roll the chart on the drive roller, turning the roller with one hand and guiding the chart with the other. Use the take-up roller as a guide to keep the chart straight as it winds. Oh, winds up on the drive roller. See pictorial 13B. So, yeah, this is just talking about all these images. All right, so I guess I'll have to see if I can make sense of this by opening or by taking apart the roll chart components. Actually, before I do that, I'm going to remove the power cord just so that it's not like flapping around and interfering with things. Okay, that really was not bad at all. So I'd been trying to make some sense of the instructions in the assembly manual, but I think what I need to do is maybe remove these retainers, undo that screw, and then pull this plate off and allow this roller to like swing up a bit, like more towards the back. That way when it tightens up towards the, like one end or the other, it has enough room to move closer to the other cylinder without touching it. I think what may have happened is that maybe at some point somebody accidentally tore the sheets and they had to take it apart to tape it up. You can see that there's some tape behind it. It's kind of like leaked through the paper. And if we roll it this way, you can see that there's masking tape back there. So yeah, the paper is torn. So I think maybe when whoever tried to fix that, to remove these, they didn't put it back in the correct position where it was going to allow enough movement so that it didn't rub against the other side. So after removing these retainers, I'll be able to pull these off to the side, bring the cylinder further to the back, place these two arms, and then hopefully then it won't rub and it'll be able to completely turn in one direction or the other. So let's see if that helps. So first of all, I'm going to undo the springs. Whoa, and one just flew off. Okay, I see it. Whew. And I've already loosened up this retainer, so now this little arm can come off. And I need to do the one on the other side. The bad part is they didn't position both at the same spot, so I'm having to turn this so I can get to the other screw. So I'm going to try to bring it up this way. I want to try to get the teeth so that they're properly aligned with each other. Okay, I think that might work. Okay, so I replaced the springs, and I think maybe I have this one on a little too tight. It's having trouble freely swinging. Okay, that should be good. Let's see if now I can go all the way from one side to the other with no issues. Yep, that got all the way to the end. Now let's see if we can go the other direction and get to the stop on that side. Well, this is a little concerning. It's it gets a lot of slack in like one spot there, and then it has a hard time tensioning up. I think that might be because of this retainer. Maybe I need to adjust that. See, right there. But it could also be because of the position, because I have it upside down, so gravity's kind of like acting on it. I think if it's right side up, it probably won't do that. And there we go. So it got to the other side, so I think that'll work. Yeah, I think I'm going to need to adjust it a little bit and get it better aligned. You can kind of see how on this side here, it's almost like parallel to the bar, and then on this side, it's kind of like tapered up. So I need to move this a little bit. But I think after a little bit of adjustment, this should be fine. So now that I've got the roll chart working properly, I'm working on cleaning up some of the external stuff. And I don't know how obvious it's going to be, but the knobs, this one hasn't been cleaned yet. I already cleaned these two. You can see how the silver stuff or the aluminum insert in there has a slight yellow tinge to it. When they clean up a nice and silver. So I still need to clean both on this side. And what I'm doing for that is I'm just taking them, putting them on like a napkin, and then just spraying the outside with a little bit of a glass cleaner. And then I'm just taking a brush, giving it a quick scrub, and that seems to loosen up a lot of the stuff that's built up on the surface. And then I can scrub all these little ridges on the outside of the knob. So give that a little bit of a scrub, just loosen everything up. I think that this is probably discolored as well. It's kind of like turned yellow, but I don't think there's anything I can do about that. That's just plastic itself. And we can see all the stuff that comes out of it. So they're pretty dirty, but they do clean up pretty well. So there we go. It has like a little, like a few little scuffs and stuff inside, but nothing too bad. They actually look pretty good once they're cleaned. The inside of the knobs, they're dirty as well, but a little Q-tip with some glass cleaners taking care of it pretty quickly. And with all the knobs in the front cleaned up, I'm now going to focus on these levers. And the sides are, on all of these, are kind of dirty, but those are easy to get to if I just kind of like scrub them like that. You can see that stuff that's on them comes off pretty easily. Yeah, they clean up pretty well. I am going to have to spray them with the contact cleaner though, but I'm not going to use the other one that I normally use. I'm kind of mad at that one for leaking. I'm going to try this stuff and see how well it works. Although I do need to be careful. I don't want to spray the paper, so I'm going to try to find a way to maybe cover that up before I'm going to try to just kind of dab it where the contacts are. I don't want to like spray it everywhere. Or alternatively, I might even just spray this in like a little container or something and then just use a swab to go in there and try to, dab it on. I don't know. Guess I'll figure that out. But for now, I got to clean all this gunk off all these levers. There's also a few here that are kind of bent, like that one. And actually, maybe just that one. They're slightly off center on some of these, but this one definitely needs to be bent back a little bit. I've got all the front wafer switches cleaned up, as well as all the rotary ones that are like all over the front of the case. And so what I did to protect the paper is I put a sheet of aluminum foil. That way, if like anything splashed, it wouldn't hit the paper. And then I also put a piece of like a napkin underneath where all the switches were to catch like anything that might drip or like spray. So that helped quite a bit. The paper looks pretty good still. I also cleaned all the rotary switches. And for those, I took one of the little acid brushes and like I soaked it in isopropyl alcohol, gave everything a scrub. And then I ended up still using this stuff to apply to the contacts because that other like quick drying electronic cleaner, it seems to be more of an acetone based product, so it doesn't leave like any lubrication on any of the switches. So after I spray that other stuff there, everything is nice and smooth. I did have to lubricate these a little bit, like up in the front, because after I sprayed them clean, they were like really hard to turn on some of them. Not all of them, but some of them were like a lot more difficult to push up and down. But everything looks pretty good. I did check the resistance on like a lot of the switches, and everything looks like it's making proper contact. I also sprayed some contact cleaner inside of the rheostat, and then I just checked to make sure that the resistance on it wasn't like all jumpy or anything. And it looks like it's pretty linear, so that's pretty good. I also sprayed the two switches in the front, and so those are making a pretty good contact now, so I'm pretty happy with that. All the little knobs that fit over the levers, those all cleaned up pretty well. There is one that had a little crack, but I ended up just super gluing that back on. It's not really a functional thing. It's more of just like the body of the knob, but I put that back on there, so everything is in pretty good shape otherwise. So the only thing left to do now is to replace this capacitor. I still got to decide whether or not I want to replace this diode. Like I said, I don't know if that's actually a selenium diode or not. I looked through the manual. It doesn't really specify. And then I just have to jump like from one of these points on the switch over to right there for the, if I'm going to use that 1N4004 diode, which I guess I probably will. The only thing that it's used for is just for setting the line voltage switch, which is this one. So this just sets it so that you have like the proper voltage being applied to whatever tube you're testing. And so that's just used for rectifying the voltages coming out of the transformer. As far as the plug goes, the new cord, I can't reuse the grommet that came originally with it. The new cord does not fit. It's like way too big for it. So what I'm going to do instead is I just got a more of like a little generic like rubber grommet that I can fit into the same opening. That way I don't have to like do any physical modifications to the case. And so that fits in there just like that. And that's big enough that now I can stick in my new cord. So on the opposite side, I'm just going to like maybe tie a knot into it and then solder it onto the 2 terminals that are like directly behind it. And that should be it for that. I did determine that the wire on the right side, that's the one that goes directly to the switch. So the other side goes directly into the transformer. So that's the one that I don't want to put the live wire on. It's going to go on that one. I guess we'll find out if the lamps that are down on those bases, if those work. I mean, they're only for like lighting up the roll chart. Oh, and I did go through and check the resistors. They all seem to be, reading properly. And I don't think there's like a lot of current going through all these or anything, except for maybe like these two that are a little bit bigger. But all the other smaller stuff, it's just like small signal stuff, I believe. And then there's a few other resistors on the back of this wafer switch. Those all were tested fine. I'm going to replace the capacitor. I'm just going to replace the diode, or basically just take this one out of circuit by just removing the wires. Or just removing one wire, really. That's all it's really needed. No, I shouldn't do both, just to be on the safe side. I don't want anything like floating around. Yeah, so I'll do that. I'll just have to add like a bit of wire to the diode so that it can extend the entire length, because otherwise it's kind of short. And then attach the new cord, and this should be ready to go. The new capacitor's in place, and the new diode is installed. And I'm just concerned a little bit about the electrical properties of the new diode being significantly different than the original diode. As you can see, I've already got the original diode out of circuit. And I just say that because this diode is used for rectifying power coming out of the transformer so that we can set the proper line voltage so that the rest of the controls are like as accurate as they can be. I don't know if the new one is going to give us, the exact same readings, or at least very close readings to what the original did. And if we look at this page in the assembly manual, that is that diode. One thing that I do know about these older devices with these older style diodes is that the diodes are drawn backwards to what they would normally be nowadays. So instead of the cathode being connected directly to the switch, as we can see on this diagram, and the anode being connected to and between those two resistors, actually had to put the cathode of the new diode connected to the center of both of those resistors, and the anode connected to the switch. And as we can see here, this, like the way it's on here with a normal or a modern diode, this doesn't make sense because we've got positive to the meter, and that means that we need negative on the meter on that side. So if this thing was in this orientation, we wouldn't get any current flow to that side. So I did check it, and sure enough, this did match to where this is the cathode and this would be the anode. So this should be correct. And as far as the capacitor goes, I tried to position it so that the outer foil side of like the wound foil inside of the capacitor, the outer one was connected to the transformer. And I tried to check that with the scope to try to get like which side was actually the outer foil side. And I think I got it. Like it tested very similar in both directions. And the way I did that is I clipped the ground from the scope probe to like one pin, and then I connected the probe side to one of the other pins. And then you just kind of touch it and see, which side produces the most like interference, or it acts more like an antenna. And so the side that I believe is the foil side ended up being that one, which would have meant that the inner foil was going to be this one. So it doesn't matter too much, I don't think, for like this particular type of circuit, but I don't think it could hurt to, orient it that way. And the power cord is also done. I just split a portion of it down the middle. Then I tied a knot, and I also used a zip tie to prevent it from being able to get pulled out from the grommet. So this is all ready to go. We can give it a little run. So I think we can plug this in now, and we can check and see if the set line voltage works properly. And if we set the filament voltage to any one of these values, we can check and see if the voltage coming out of like a socket, like matches whatever is set to on the filament settings. But I guess for now, let's just make sure that nothing goes up in flames, or I mean, it's really not like a crazy high-powered piece of test equipment or anything like that. So nothing really should happen. So here I go, plugging it in. And nothing should happen just yet. I guess we'll see if the lights come on. And so set line, let's turn it on. Okay, that goes on, and it looks like, yeah, the light bulbs did light up. I can't tell if it's both of them from here or not. I don't really want to reach around the back because it is open and it is kind of dangerous now. So I'm going to be careful about not reaching back there or anything. So let's go up to this line, should go up to where it says line test. I can't really zoom this in anymore, but I guess that's going to have to do. And so we're going to go up a little bit more. Not yet. A little more. A little more. And it's basically like right there. Now, unfortunately, I don't have any known good tubes. As far as I'm aware, these 4 that I have in this little container are not good tubes. I don't know to what extent, but we can try to pop them in this thing and see if they will work. I have a 12 BE6 that I'm holding, and then I also have, this is a 12 AV6. I think there's 2 of each in this container. So I'm going to set, well, I'm going to look up the settings for a 12BE6 in the roller chart. Turns out I was going the wrong way. Here we go. I'm at 12, what did I say, BE? 12, there we go, 12BE6. So we're going to set the type to 2. So that's this switch. And then we're going to set the filament to 12.6. The plate, it says 24. So about right there. And then the top settings are going to be A. So we're going to push A up. And then B, D are going to be down. So B and D are down. Okay, and I've got the multimeter up in the shot. We're going to check the voltage. And I do not know my tubes very well at all. So I know that 2 of the pins should be the filament voltage. I'm not sure if it's in this position or if it's, so 15.15. I mean, it's more than 12.6. I don't know how much that voltage is going to drop with a load, but let's see if I turn this down. 14.4, 13.7, 12.6 right there. So I think maybe having that diode in circuit is throwing things off. Well, I'm actually kind of curious now. So I'm going to put the old diode back into the circuit, and I'm just going to disconnect one of the leads from the new diode. And at all the same exact settings, let's see what the line test does. And then we'll check the voltage at the socket and see what it tells us. Okay, I've got the original diode reinstalled. And I'm going to plug the tube checker back in, and I have not changed any of the knob settings, and the line is exactly in the same spot that it was. And let's see what happens now with the line test. And yeah, it went up higher. So let's see what the voltage says at the socket. Yeah, that's about 12.6. So this would be the right setting, but the meter there doesn't give us the exact same results with the other diode. So I guess I'm leaving the original diode in place, and I guess we can check this tube then and see what sort of a reading this checker gives us. So I'm going to plug that into this socket and then give it a little bit of time to warm up. And I can see from the back that it is glowing. Actually, let's turn off some of this lighting. You can kind of see it glowing right there, just a little bit. Okay, so I think all I have to do is, well, this here checks for shorts, and if it's shorted, this would light up, I believe. And this checks for leakage, and it doesn't look like this tube has any leakage. So I think the next thing we do is just hit this test switch here. I'm gonna have to go through the manual and actually read how you're supposed to use this, but let's see. Oh wow, it actually says it's good. Interesting. So maybe when I had originally checked this on like this other tube tester that somebody else had like a very long time ago, maybe there was nothing wrong with this tube after all. So I think I do have another one of these. Yeah, I do have another 12BE6. So I'm going to swap it out, and then I'll just give it a few seconds to warm up. And I seem to have hurt myself somehow. Okay, that's definitely glowing. And let's, oh, I forgot that we have 2 to check on each one, so I only checked one of them. I need to check the other one. Anyways, let's see what this one says. It's in the good, and it actually looks like it went further than the other one. I forgot to do the leakage and the short check. Okay, so it looks like I did do the testing correctly. There is one other check that it mentions here to do on number 10. It says to check for open elements as follows. You hold the slide switch in the test position, and then you move each lever in the top position. And then it says only those shown in light type. And I think what it means there is that it looks like some of the letters here are a little bit more bold than some of the other ones. So I think like when they are kind of light, that's the ones that you can actually move to do the element test. So in this case, A right there looks like it's pretty light. So if we hold down the test and then we move A all the way down, it says that the reading here should move in this direction. And it depends on what exactly you're testing. It might move a little bit or it might move a lot. So in this case for A, it moves quite a bit. So I guess that means that that's good. And there's a lot more information in here that I'm not going to go through at the moment. But let's just check and see what these tubes that I have on hand do. So we can check the other side of this tube by putting E, F, and G to the top side and putting leaving B and D at the bottom. So A can go back to the center, and E, F, and G go up. So E, F, G. And yeah, those stay the same. So if we hit test, I guess that side also tests good. And since these are kind of light text, let's see what happens when we push these down. So that moved a little bit, not much, and that's kind of what it said. Sometimes it would just move a little bit. That one moves down quite a bit. And this one, just a little tiny bit. So this tube appears to be good. Let's check the other 12BE6 and check the other side that I didn't check the first time. Okay, so that's glowing once again. Let's go ahead and hit test. And yeah, we can see that this one doesn't swing quite as far as the other tube did. And we can check these as well. That just dropped down a little tiny bit. That dropped down a lot. And that just dropped down a little tiny bit. So yeah, I guess these 2 tubes are good according to this. Like I said, I don't have like any other way of checking these. So let's check the other 2, and I'll see if any of them are bad. I'm not going to go through the entire procedure again. Well, according to this 12AV6 is no good on the first one. It says AG to the top. So if I do this again, put A and G up, we test that. That one moves over to the good side. But then if we do E, so we're going to put A and G back in the center, push E up. If we check that one, that one goes over to the bad side. And then if we put E down and we put, or back in the middle, we put F up, which is the next one. Oh, wait, I forgot to change the voltage. Okay, and now with the filament voltage up to about 43, which is what it says on the plate. If we check E, it actually still goes over to the bad side, but is not as bad. And then F actually does move to the good side. So I think that means this tube is bad. And this second 12AV6, if we set it back down to 21, put A and G up, and everything's correct. We've hit test. That goes to the good side. And then if we put these down, put E up and turn this up to 43, it goes towards the bad side, but then it starts creeping up into the questionable area. And E down and F up. And it just slightly right of the questionable area, so I guess both of these two 12AV6s don't appear to be good tubes anymore. The only other tube I have on hand that I can try to check that I'm pretty sure is bad is this 6BG6, and it sounds like there's something rattling around in there, so I'm wondering if this one's going to show us a short or something. So I already have the chart pulled up, and for 6BG6, we're going to set the type to 3. 6.3, going to do 24 on the plate. E, H, N, and CG. Okay, and this one's going to use the plate cap clip. So let's see, which socket does this go in? And we pull this out and clip it to the cap. And it is glowing. Going to let that warm up for a bit. So the switch is on short. This is not lighting up. Let's try leakage. It still didn't light up. So let's go ahead and hit test. Oh, bad. I was cleaning up the back cover, getting ready to put it back on, when I realized that this was taped to the inside of it. And that's like the little line there that you would have used to, try to like keep which particular tube you're looking at in line. So I'm wondering if maybe that fell off at some point and that's what caused the paper to rip. But the only way to get that back in there would be to take apart most of the chassis, because it's going to be like way inside there. So I'm not going to bother with that. I'm just going to leave it out. And I didn't even think this thing was included, but I guess they taped it in there in case they ever wanted to reinstall it at some point. And you can tell that there was some adhesive there. So at some point it must have just like fallen off. And the last thing I wanted to look at was to see what's going on with this socket. See if it's just straight through or if there's something inside or what. So it just has the tape holding it together, it seems. I am not sure what brand that's supposed to be. It's missing a lot of the text. And so it's just straight through. That's it. No idea why this would be on there. Maybe it's just something that whoever used to own this thing used for whatever particular reason. So, yeah, no idea. Oh, and one other quick little thing. I think we went to the wrong year. On the roller, it says 1172. So this must have been made a little bit later than I thought it was originally made. And then it says right here, copyright 1971. So we just have to adjust our time circuits a little bit. And then I think we'll be a little bit closer to this thing's like actual build date. And with all that, that's going to do it for this one. It's really not in bad shape at all. I was actually pleasantly surprised that we didn't have to do like a lot of stuff to it. And other than like a little bit of staining on the outside, I mean, it is an older used tool, so that has to be expected. There's like no serious cosmetic damage to this one or anything. I think it's going to suit my needs just fine, or at least I hope that it's able to help me with what I want. So that's going to do it for this video, and thank you all for watching. I will see you guys around the bench.